In this video, I'm going to work out two examples of simplifying radicals. Straightforward simplifying radicals. I am assuming that you've had some background with this, you've been doing some of these problems, and you just need to see some more examples. The directions are going to say simplify each expression, and we are going to assume that the value of each variable is positive. That way we do not have to use the absolute value bars. Alright, so for this first example, I've got 27ab to the third raised to the 1/3 power times the cube root of 5a to the 4th b. Since this is a cube root and this is raised to the 1/3 power, then I think I'm going to choose to rewrite this in radical form as a cube root. So I would have the cube root of 27ab to the third. I'm not going to do anything to this second term, I'm just going to leave it. Now, under normal circumstances, I would probably just go ahead and multiply everything out and have a great big cube root that I would then simplify. However, taking a look at these two numbers, the cube root of 27 is a perfect cube. So I don't want to multiply those together because then I would just have to turn around and undo that to have a perfect cube root. My a's, when multiplying like bases, I can add those exponents. Neither one of them is a perfect cube, so that is what I'm going to do to those. And then on the b's, here again, my b to the third, alright, is a perfect cube root, so I do not want to choose to multiply those together because then I just have to separate it again. But I am going to do some rearranging of terms here, so I'm going to do cube root of my 27. Alright, and then I'm gonna totally rearrange here times my cube root of 5, just so I've got all my numbers together, all my variables, matching variables together. Alright, now for my a's, since neither one of those are a cube root, then I'm going to go ahead and when multiplying like bases, add the exponents, and keep it in mind there is a little imaginary 1 right there, so that would give me the cube root of a to the 5th. Alright, and then because b to the third is a perfect cube, I'm going to leave those two separated. So cube root of b to the third, and then cube root of a b. Alright, now as I go through and do my next line, I know this is a perfect cube. Alright, it's a perfect cube of 3. Alright, this is not a perfect cube, so I'm going to leave it alone. It's going to remain under the radical. Alright, now for my 5, a to the 5th power here, I've got to see if I can come up with a perfect cube. Alright, I have 5 a's there. I know if I had at least 3, just like this one, if I had an a to the third, I would have a perfect cube. That would have 2 a's left over. So I'm going to break this one up into the cube root of a to the third times the cube root of a squared. Alright, so those two come from my a to the 5th. Alright, this term right here is a perfect cube, so I can go ahead and take the cube root of that and give myself a b, and I cannot simplify this at all, so it's going to stay as a cube root of b. Okay, now simplifying one more time, this is a perfect cube, so I know this goes to an a. Alright, everything else has already been simplified the best that it can be. So now I am done, and I can put together everything that I have taken a cube root of and pulled out. Everything that's underneath the cube root is going to stay underneath the cube root. So that looks like I'm going to have a 3 and an a and a b on the outside. Underneath my cube root, I will have a 5. And also an a squared and a b. Alright, and keep it in mind there that, you know, we're always only using positive values for my variables there. Alright, so for the second example, it's a quotient, and I have a square root on the bottom and something raised to the 1/2 power on the top. So again, just like I did on this one, I think I'm going to take this and turn it into radical form. So I'll keep the 8 on top, make that the square root of 54x to the 5th. And then a 4 square root of 3x to the third. Okay, now looking at this, neither one of these are perfect square roots. So I think it's going to be to our advantage as to write this as one great big radical and then do some simplifying underneath that. The 8 and the 4 out in front, since they're just kind of like coefficients to those radicals, I can go ahead and simplify those out in front. So then I would have a 2, writing that as a big radical. I would have 54x to the 5th over a 3x to the 3rd. Alright, and now we can simplify underneath that radical. 54 divided by 3 is going to give me an 18. And then when dividing like bases, I subtract the exponents there. So I would be down to a 2 square root of an 18x squared. Now you're back to simplifying just a plain radical here. I'm going to try to break each of these up into a perfect square root. X squared is a perfect square root, so I don't have to worry about doing anything with that, but this, I need to pick the biggest perfect square root that goes into 18, which is going to be a 9. So the 2 is going to stay there. I'm going to break that up into the square root of 9 times the square root of 2. Alright, now I'm going to go ahead and write it as that way so we can see it. Square root of x squared separated out. Alright, the square root of 9 I can take as 3. The square root of x squared I can take as an x. Alright, square root of 2, and the 2 which is already outside is done. Alright, so 2 times 3 times the x on the outside is going to give me a 6x. And then the only thing left under the radical there would be the square root of 2. And again, assuming that all those variables are positive, we do not have to mess with any absolute value bars. Alright, so just a couple examples of simplifying radicals, and I did assume that you had a background and had already done that before and just need to see some techniques with some more examples. Definitely thanks for watching. Be sure and give me a thumbs up, subscribe to my channel, and share with your friends. Thanks.